All right, so we'll go ahead and get started. We got the review for today. Your test is going to be tomorrow. And so you have all day to do that. There's no lecture tomorrow, so you have all day to take the test. We're going to do the version B today because some of the version Bs are a little bit closer to what's going to be actually on the test. And so we'll do this version today, version A, then you can try on your own, and got the answer key and videos on my website for that if you want to see those. So we'll start here with 1B. So again, this test is going to have 12 questions on it. And they're, again, very similar to the ones that are on here. We'll just have some different numbers and things. So it says, write a degree 5 polynomial with a leading coefficient of 1 that has these zeros. So to start this out, what we're going to do is we're going to start with the f of x equals, of course. So f of x, get rid of that box here, f of x equals. So since the leading coefficient is 1, I don't need to worry about putting anything there. What I'm going to do is I'm going to put 5 parentheses here. I'm going to start all of them with x minus. So I'm just going to put x minus. That's the first thing that you're going to do. So whenever you want to take a 0 and turn it into a factor, you're just going to do x minus, and then you just have all of them there. And we'll put all these in. So if I do x minus, so I have x minus -5, I have x minus -2, I have x minus 0, x minus 1, x minus 6. And now I just need to simplify this. Now this middle one is going to be just an x. So if you have just an x, then you can just go ahead and put that out front. And then the rest of them, it doesn't really matter the order. Now this is going to be x plus 5, minus minus, and x plus 2. We already got the x already. And then x minus 1, x minus 6. Okay, so this here, this whole thing, that would be your answer on this one. So again, we've got all 5 of these are done. So even if you have a 0 on it, you need an x. Now, something to keep in mind is that if you don't have a 0, then you're not going to have an x out front. This is something I see on every single test. Students will put an x out here because the sample one had an x. Well, it's only an x out front if there's a 0 on one of this list that they give you. If a 0 does not appear in that list, then you're not going to have a single x term out front. So I want to make that clear. The x is only there because we're doing x minus 0. If this 0 was not given on the list, the x would not be there, and you'd only have these other 4 parentheses that you'd have there instead. So just want to make that clear. Okay, so then for number 2, it's going to ask you to find the intercepts and use any kind of method. So on 2A, you could probably do that one by factoring. So factoring is one method you could do. But I want to look at this one as well. This is one where you have to find it by using the square root principle we're going to use on this. So first of all, let's do the x-intercept is where you put in a 0 for y. So we have 0 equals 2 minus x squared minus 5. If you're going to do it, solve this by using the square root method, then you want to make sure that this square is isolated on one side of the equation. So the 5, we're going to move that over to the other side, and we get 2 minus x squared. Then you're going to square root both sides. So when you square root the part that doesn't have the x on it, don't forget you're going to put a plus or minus on it. So we're going to do plus or minus square root of 5. We have the square root of 2 minus x squared inside here. So we're taking the square root of both sides there. Now the square and square root are going to go away, and you get plus or minus root 5, and that's going to equal 2 minus x. From here, you can, if you want to add an x to the other side, you can. So we get x plus or minus root 5 to make the x positive. If you want to do that, certainly you could. Just like this, and then we can move this term over to the other side. Now, there's already a plus or minus sign in front of it, so if you move it across the equal sign, that's not going to change that. It's still going to be plus or minus. I'll still take care of those. So you have 2 plus or minus root 5 is what you'll end up with. If you subtracted the x first, then you'd have to divide everything by a negative to reverse it. So it's probably a little bit easier to add the x and then just move this term over to the other side. The order doesn't really matter here in this case, but typically you'll put the square root after the regular number there. And so you get 2 plus or minus root 5. So on the test, I want to see this one for you real fast here and just make sure that I want to see which way they're asking you to type these in so I can let you guys know what you have. So if you go to the test on here and we take a look at the questions that are on it. Okay, so this one on the test, you don't have to worry about putting the parentheses and the zeros on there. It just asks you to list it. So it will say that in the questions. All you have to do is just list both of them. So if it was this as the answer, you would have to do 2 plus root 5, and then 2 minus root 5. The one in the test may or may not have fractions or square roots in them. This one does. So if this was one of them, I'd be putting in my open math. I would just put one with a plus, comma, and then with a minus on there and just list them like that. Same with the Y-intercept. You only have to list just the number only. So if we do the Y-intercept, that's where you put a 0 in for x. So we're going to do 2 minus 0 squared minus 5. And then we just have to compute this. So 2 squared is going to give you a 4, 4 minus 5. And so we get -1 there. Again, this one, it does not require you to put a 0 in there at all. All you have to do is just enter the number only. So it'll actually say specifically in the instructions, do not write in coordinate format. So I just wanted to make sure we understood that. Okay, so next one we'll do is number 3, part B. Okay, so this one, they want you just to solve it. Okay, so solving it with this, now this one is going to require you to use the quadratic, actually, let's try and factor this first. We can factor out of 2. Okay, so actually, since we have it equal to 0, if you see a problem like this where everything is divisible by a certain number, then what we can do is divide the whole thing by that number. So since there's a 2 out front here, I'm just going to divide both sides by 2 to get rid of it. That's going to make my number smaller, and that'll help us to see whether it can be factored or not. So I'll do that step first and just divide everything by 2. And really, you only want to do that if you notice a common factor, then go ahead and do that. Otherwise, you could just go ahead and, if you wanted to solve this by quadratic, for instance, you could just put all the numbers in there. But then you might get you'll have b squared minus 4ac, you'll get some big numbers inside, and it might be hard to simplify it. So either case, you still want to go ahead and divide that common factor out just to make the numbers smaller. Now we can see here that we do still have to use quadratic formula because factors of 7 that add up to 4, there is none. Okay, so we're going to have to use quadratic. So a is equal to 1, b is equal to -4, and c is equal to -7. Okay, the formula, so you want to make sure that you know this formula, -b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. So you want to make sure you have that because you may need to use it on the test. So now we'll just put in the a, b, and c that we've already identified. We have negative times -4 plus or minus the square root b squared, so -4 squared minus 4 times ac. A is 1 and c is -7. All that is going to be over 2 times a, or 2 times 1. Okay, so we have all that. Okay, so next we're going to simplify. We want to simplify this down as much as possible. We have 4 plus or minus the square root. We have 16 plus 28 inside, because we have negative and negative, all over 2. Okay. That's going to give us the square root of, so let me erase this here so we have a little bit more room. And if we put that in, we're going to get 4 plus or minus square root of 44 over 2. And we want to break this down further. So square root of 44, this right here, we can write that as 4 square root of 11, because, I'm sorry, 2 square root of 11. So 2 square root of 11. That's because 44 can be broken down into 4 times 11, and square root of 4 is 2, so 2 is going to come outside the absolute value sign. So if I have, so all this here, I have 4 plus or minus 2 square root of 11 over 2, and you want to divide each of these by 2, so you get 2 plus or minus root 11, and that's going to be the answer for this one here. So you probably want to just put 2 plus or minus root 11 as your answer here, but I kind of ran out of room down below, so I just wanted to show you that's what would happen. When you change it into 2 root 11 over 2, each of these, you just divide each of these by 2 to get the final answer there. So make sure you divide both by 2, not just the first number. Everything on top is being divided by 2. So that's your answer. All right, so next one is the 4b. Now this, one thing you want to know for this problem here is the different powers of I. So I to the 0 is equal to 1. This is just number 1. I squared is equal to negative 1. I to the, I skipped I to the first power. Okay, I to the first power, of course, is just, I to the first power is just I, so we have that one. And then we have I squared is equal to negative 1. And then I to the third power is equal to negative I. So you want to know those 4, and the pattern repeats itself again. So when you get to I to the fourth power, it just goes back to I to the 0, and then just repeats. It goes 1, I, negative 1, negative I, and then it just keeps repeating the same pattern over and over again there. So when you, you'll just keep repeating itself over and over. All right, so so that right there is your pattern. So because it repeats every 4 times there, what you want to do is you always will take the power and divide it by 4. Okay, so if we divide it by 4, then you're going to get, it goes in twice, so 8 there, 28, and then there's a 7 there. So this goes in evenly. There's a remainder of 0. Okay, so I to the 0, look at our list, is equal to 1, and that's going to be the answer for this problem, I to the first power. So whatever it is, just divide it by 4. You always will get a remainder between 0 and 3. You always will get whatever it is. You just look at the chart, and that's going to tell you what it simplifies to. So whatever the remainder is, you'll just write that number down. So these 4, that's something else you want to know on the test. You want to know quadratic formula, and you also want to know this right here, this list. You want to have that nearby when you take the test. Okay, so next one is 5 part B. So the one like this where you want to divide this. So to do these kind of problems, you have to multiply the whole thing by the top and bottom. You'll multiply by the conjugate of the bottom. Conjugate is the same thing on the bottom, except we have a plus sign instead of a minus sign. So 52i divided by 2 minus 3i. We're going to multiply this by 2 plus 3i top and bottom. Okay, so 2 plus 3i top and bottom. And you'll just multiply across the top and across the bottom. So if you multiply across the top, we just have one thing up here. So 52i times 2 is, we'll multiply that. So we have 104 I, and then don't forget that because we have two i's multiplied together, that's an I squared. So you get 156 for the numbers, but don't forget to put I squared on this. Whenever you have an I and an I multiplied together, it's I squared. Now on the bottom, we're going to do, we have a 4 here, and then you have a plus 6i, the inside terms minus 6i, and then you have these two, it's going to be minus 9i squared. Okay. The next thing is anytime you see I squared, we just talked about that in the previous problem up here, I squared is equal to -1. And so we're going to put that in here. So we're going to do 104 plus 156 I squared is -1. You put in there. Now on the bottom, the 6 i's are going to cancel out. So we get 4 minus 9, and then -1 goes in there for I squared. Okay, and there's an I lost here. There's an I that goes up there on top as well. All right, so next thing we'll do is we're going to rearrange this and put the, on top, we want to put the -156 first because we want to put this in the standard form. And then on the bottom, we get a 13 is what this is going to simplify to. Now each thing on top, you want to divide by 13. Okay, so both things get divided by 13 here. And it just so happens that this is going to simplify down into, we don't have any fractions here, but you could possibly have a fraction here as part of your answer as well, but this one you don't. It's just going to be -12 plus 8i. And don't factor this because for the standard form, just leave it the way it is. So you don't need to factor this one. Okay, so that's your final answer. So always a key to remember on number 5, multiply top and bottom by the conjugate of the bottom. Okay, so instead of a minus, we do a plus. All right, 6b is one where you want to change both of these into imaginary numbers. So we did do this, a couple of these before, where we have in that section, we did these individually, but we didn't do one where we have it multiplied together. So with it multiplied together, the only thing you want to remember is don't multiply this and make it square root of 200. That's the wrong way of doing this kind of problem. You're not going to get the correct answer if you do it that way. Instead, because these are both negatives, you want to change both of them into imaginary numbers first before you multiply. That's the most important thing about this problem. So first, each of these I'm going to break down. So 40 goes into 4 and 10. And so I can write this as 4 times 10 times -1, just like that. And the other one is, I can't do anything with the square root of 5, but what I'll do is I'll just write this as 5 times -1, just like this. So each of these I can do square root of 4 times square root of 10 times square root of -1. And this one I can do square root of 5 times square root of -1. So this first one, the square root of 4 is 2. And then square root of -1 is an I. I'll put the I on the outside of the square root there. And then this one, there's another I that goes in front of the square root of 5. Again, I put them out front because if you put them afterwards, then it might be a little confusing to know whether that's inside or outside the root if you look back at that later. So that's why I put them out front like that, so then you know for sure they're outside of the radicals. Now that I have this complete, what I'm going to do is multiply like things together. I'm going to put the like things together here. So I have 2 times I times root 10 times root 5. So if I multiply all this is all multiplication. So if I multiply all that, 2i squared, and then the square root of 50 I get afterwards. Now the I squared is going to turn to -1, and then square root of 50 or the number 50, I should say here, 50. I want to look for the biggest square. So that goes into 25 times 2. So 25 is a perfect square there. So I'm going to do a -1 inside here. And then this is going to be the square root of 25 times 2. That means square root of 25 is a 5 that comes out. So I'll just get 5 square root of 2. And then finally, I can multiply all this together out front. -10 square root of 2 I get for that one. And that would be your final answer. So this is -10 root 2. So you kind of just break down each one individually and just treat both of these as like two separate problems, writing them both in terms of I. And you're just looking for the biggest square you can take out of here. So 40, certainly I could have done 5 times 8 or something like that, but I want to look for what's the biggest square that goes into this into this here. And so that would be a 4 and a 10. The 4 would be the biggest perfect square that would divide evenly into that. Okay, so for that one, what you're left with, square root of 10, that's just 2 times 5, so nothing comes out of that one there. And then you break them down into both the i's and you get the negative out front like that. So that would be that's your final answer. Number 7 is one of these kind of problems where you have to graph something. It's either going to be one like this, where it is parts 7a, you would have to use the vertex formula there in order to find the vertex -b over 2a. And so I'm not going to do number 7, but I'll just go ahead and put that this one, you would need to use -b over 2a there as the formula, because you have your a, b, and c given in that one. So that right there, you'll have to use for number 7a, and you'll just plug those numbers in and get the vertex. For 7b, you don't have to use that formula because it's already given to you in the vertex form. Now, if it's the vertex form of that, the vertex form kind of looks like this. It's a, and then you have x minus h squared plus k. So the vertex is your h and k that you have here. That's what gives us allows you to pull it out directly from the formula. So we'll do that here. Now, when you do the parenthesis part, you're just going to take the opposite sign of what's inside the parentheses, and you're going to use the same sign as the one on the outside. So for this, your vertex, we can automatically get directly from the formula. We didn't use any -b over 2a. No need to use that on this problem because it's already written out in the vertex form. So the one that tests will either give you one in the vertex form or it'll give you one like the one before. You do want to know how to do both of those. Definitely, for sure, you'll have to use the vertex formula at least once on the test. So you do want to know how to do that one as well. Axis of symmetry is just x equals, and you just put the x value from the vertex. So axis of symmetry is just x equals 3. Now the rest of these, the intercepts, okay, we'll just follow the same way we did before. So for that, for the x-intercept, you want to put in a 0 for y. So I have 0 equals -x minus 3 squared plus 4. And I'm going to solve this by using the square root principle we used before on a previous problem. Okay, so I'm going to erase this because now we know what the vertex form is, just to give us some space here. All right, so now with this, we'll move this over to the other side. Okay, so we've got x minus 3 squared equals 4. So we move the negative over to the left-hand side. Now we want to take the square root of both sides. Now when you do, you're going to get plus or minus 2 here when you take the square root of both sides. Remember, there's always plus and minus for that. So we'll have x minus 3 equals 2 and x minus 3 equals -2. Then we get x is equal to 5 and we get x is equal to 1 for both of those. Now we could have expanded all this and factored it. That's another way we could have solved that, but it's going to be easier if we do this here. So let's do 1 and 5. Those are the intercepts there. And now we just have to find the y-intercept. The y-intercept, you find that by putting in a 0 for x. And so we get negative 0 minus 3 squared plus 4. All right, now inside, we have negative 3 squared is going to be a 9. So we get negative 9 we end up with here. The negative on the outside remains, and that carries down. The negative on the inside goes away because of the square you have. So that's negative 9 plus 4, and y is going to equal negative 5. Okay, so negative 5 is your y-intercept. Let's graph this first, then we'll take a look at the range later. So 3, 4, 3, and 4. Plot that. And we have the 1 and 5. 1 and 5 are the intercepts. We have a negative 5. Now notice that all the points that we have, they all line up, and it makes sense that you should have some kind of curve. If you have points that, one ends up way over here and it's all lopsided, then you want to go back and double check your work. It should be a U shape when you have that one. Okay. Also, when you do these in the graphing tool in MyOpenMath, you're going to have to click on the vertex first, and then you click on one of the other intercepts in order to graph that. Okay, so the graph will look like this. Okay, it's going to be something like that. That's what the graph looks like. You don't have to worry about showing the axis of symmetry on here. That's fine. Okay, but this will be the upside down U shape. It makes sense it's upside down because there was a negative out in front of that was your A value. And we're talking about the vertex formula. So there's an A there that's negative. That tells you the graph opens down. Now for the range we're going to use the graph in order to get that. So that goes all the way down to negative infinity, and the highest it's going to go up to is going to be a 4. So your range is going to be from negative infinity to 4, and 4 is going to have a bracket on it because that number is closed. Okay, so that's an actual point on the graph itself. That is the vertex. It does exist on the graph. And so in that case, that's why you have to put the bracket on that one, and you want to include it. Okay, so that would be that's your final answer on that one. Okay, 8B is going to be some kind of a word problem on that. And so both of these kind of problems involve you setting up two equations and plugging one into the other. So this is one that we've seen before, a fencing problem. So we'll do that here. So this particular one asks you to find a function a of x that models what we're doing, and then we want to find the maximum area that can be enclosed. All right, so first thing we want to do is we want to set up some variables on here. So if they give you this kind of fencing problem, they have to give you a picture for that. So that way you understand what the different divisions are on here. So for this, I'm going to let x equal the short ends, the shorter ends, and I'll let y equal the longer ends. You don't have to do it that way. If you want to use L's and W's, that's fine. Or switch those, makes no difference. Okay, but I'll just set it up like this, where the y is the longer side. Now, on this, fencing is being used on all of these, on all the sides all the way around. The only time this would not be the case is if this was maybe up to a lake or something like that, and so maybe the last side would just be the lake, so you wouldn't need to put fencing there. So then you would not have a y along that side. Okay, but in this case, we see all the sides are drawn in there, so we do have to put a variable next to all the sides. Now, if you add everything all up here, that should all add up to the 600. So I have 3 x's and I have 2 y's. All that adds up to 600. Okay, so I have that. From here, I can solve for either x or y. It doesn't make a difference, because ultimately what I want to do here is I want to put it into down in this part here, area equals A times X. I want to substitute either X or Y, it doesn't matter, but I'll solve for Y and plug it in there. So for this, I get 2Y equals 600 minus 3X right here. And that's if I divide everything by 2, then I get Y is equal to 300 minus 3/2 X. Now this Y is the one I'm going to put down below into here. So I'm going to take all this and put it into the Y down below. Now, once I do that, once I get rid of the Y, then I can go ahead and put A of X, because now it's a function and X is the only variable because I've replaced the Y with this expression that has an X in it. So 300 minus 3/2 X, just like that. So take out the Y, replace it with all that in the parentheses. And now that that's complete, I can put this down as my answer, but in part 2 down here, I'll have to use the vertex formula because it's asking me to find a maximum. So probably I would want to just go ahead and multiply this out. And 300x minus 3/2 x squared. So I'm going to put that here. A of x is equal to 300x minus 3/2 x squared. So it'll take either one of these answers. If this kind of problem was in my open math, it would take either the expanded version or the factored version. Either one of these it would take as an answer, but we'll just leave it like this. So that's part I. And then for double I down here, we want to use the vertex formula, which I wrote that down earlier, but the vertex formula is negative b over 2a. Now be careful with this formula that you have. The a is the number in front of the x squared, and the b is the number in front of the single x. Okay, so be careful you don't get those confused. The a is always the number in front of the squared variable. Okay, so if we put that in, we have negative 300 over 2 times negative 3/2. So if we put that in, the negatives are going to cancel out, the 2's are going to cancel out, and you're just going to get 100 in here because you just get 300 over 3, which is 100. Okay, so that's not the answer to the whole problem, though. Okay, this is the most common mistake I see students making on this kind of problem, is putting 100 in for the answer. What you found is you found the x value that gives you the maximum area, but this 100 itself is not the maximum area. Now there's 2 ways you can find the maximum area. You could just take 100 and put it back into the answer you had from part I. You could put 100 in there and work that out. Or the other way is you can find the y value and then just multiply x and y together. So I'll do that. I'll find what this area is. So I'm going to do 300 minus 3/2 times 100. Just using the formula from above that I did it up here. If you put that in there, that's going to give you 150. Both of these are going to be in terms of feet. So then if you just multiply those together, area equals x times y. So area equals 100 times 150. And each of these, actually, let me put feet in here for each one. So 150 feet times 150 feet. When you multiply that, it's going to give you 15,000, but then you have square feet. Okay, so that's how you get the square footage on that. So it's 15,000 square feet because you're multiplying 2 feet together. So again, 2 different ways you can either find x, find y, and then multiply them together, or once you have the x value, you can plug that into the 300x minus 3/2 x squared. You could do that as well. So either one of those would get you the correct answer. All right, so then, okay, so this one for 9b. So there's actually 2 problems on the test where you'll have to use the vertex formula. Part 8 is one, or question 8 is one where you have to set up some equations, plug one into the other. But now number 9, if you notice both of these questions, where they are, they give you some formulas for those. By the way, if there's any problem in the test that has you find the profit, the profit formula will be provided for you on the test. So it'll say hint or recall profit equals revenue minus cost, something like that. So if there's any kind of problem like that on there, it would give you the profit formula for it. But this one, 9B, we don't have to worry about that. It's something different. So it says a quarterback throws a football, initial velocity is 70 feet per second, angle 25 degrees. So actually, this information they give you up front here, you don't even need to use that in this problem at all. All you have to be concerned about is the main formula that they give you here for the height. So it says here for part I, determine the time at which the ball reaches its maximum height. Now, for this, you're still going to use the negative b over 2a formula. It's just that you'll have it equal to a t instead of the x, okay, because you have time in this formula, not x. So that's all you have to do, because it's got the word maximum here, and you have a quadratic. That means you're going to use the vertex formula here. Even if it said minimum, you would still use negative b over 2a. Doesn't matter which, if it says maximum or minimum, you're still going to use that formula. A is negative 16 and the b is 30.4. So let's put that in there. We're going to get negative 30.4 over 2 times negative 16. Remember that you should probably multiply that out first. Or if you're putting that into your calculator, make sure you remember to put parentheses around the whole thing. You're dividing that. So if we put that in there, and the negatives will cancel out and you get 0.95. That's going to be seconds. Okay, so 0.95, that with this model, that's how long it'll take for it to get up to the maximum height, is about 1 second. Okay, so the next thing we're going to do is we're going to find the maximum height. To do that, we just put 0.95 back into the original equation. So we're going to do h of 0.95, and then we just put 0.95 in for all of the t's. Oops, if we have to 0.4, 0.4, and then 0.95, and then plus 5. Everywhere you see a t, we're going to replace it with 0.95, and we put that in all the way. And then you just want to put that into your calculator, and so it's going to be 19.44 feet we get for that. So that would be that's the maximum height. Okay. 25 degrees is a pretty shallow angle. That's why we don't get a lot of height there, because this angle is pretty low as it is. So that would be the answer for 9B. So for number 9, there will be some kind of a quadratic formula will already be provided for you, where you don't have to substitute anything in. It'll be provided for you already. Okay, next one we have is number 10. Is going to involve the solving inequalities. And it's either going to be one like this, where there's a some kind of rational expression like you have here, something being divided, or it'll be one like this. So with this kind of problem, what you're going to do is everything you're going to that you have inside here, you want to set the things inside equal to 0 to find what are your key points that you'll have on your number line. And remember, these kind of problems, you can either use a number line method or you can use a table method that's on it. Now, when you do these kind of problems, I need to see some work. If you just put the interval down and you have no work there, okay, you need. I'm not going to give you full credit on that. You have to show work on this. Yes, I know it's possible to graph it and you can read the value off of a graph, but I still want to see some kind of work here, some kind of algebra like we showed in class. So either number line method or a table method you want to do. So I'm going to take, first of all, x plus 1 equals 0 and x minus 3 squared equals 0. If I solve this, I'm going to get negative 1. If I square root both sides, I get x minus 3 equals 0, and so x is equal to 3. These are the two numbers I'm going to put on my number line or the table. It depends on which one you want to use. Now on this problem, in the answer key, I showed a table, but I'm going to go ahead and do this one by doing the number line method, just so you can see another way of doing it. So let's do the number line method, and I'm going to put -1 and 3 in here. You want to put both numbers in order from smallest to largest inside here. Then we're just going to do a test number, a number less than -1 in between these two numbers and larger than 3. Less than -1, we're going to do -2, put in there. We have a negative and a positive, so number between negative and positive is 0 we can use. And a number larger than 3, we can use a 4. Now, if you're going to use the number line method, that means you're going to plug these into the original equation as is. Okay, so for x equals -2, and we're going to ignore the sign with a 0 and all that. We're going to get rid of that. We're just going to plug it into the first expression. So I want to do -2 plus 1, -2 minus 3 squared. I just want to see what kind of number we get as a result here. This is -1. And then this is going to be a positive 25 because we get a negative squared is positive. So this is going to give us, we don't even have to finish this. We already can see that this is going to give us a negative number. So put a negative inside there. And we have x equals 0, 0 plus 1, 0 minus 3 squared. We get a 1 times a 9. That's positive. So we'll put a plus in there. Then we have x is equal to 4, 4 plus 1, 4 minus 3 squared. This is a 5 times a 1 squared. That's all positive. So we get a plus. So this is going to be our sign configuration. We have negative, positive, positive. Now for this, we have greater than 0. If it's greater than 0, we look for positives. If it's less than 0, that means we got to look for negatives. Okay, but greater than 0 means we're going to look for positives here. Now we have to be careful of whether we include the number on the number line or not. Okay, so if we have a greater than or equal to symbol, that means we're going to include the number on the number line. But because we have a greater than symbol on it, that means that 3 should not be included in our solution, because if I have a 3 there, that means that if I plug it back in here, I will get 0 is greater than 0. That's not a true statement. So that means 3 is not included. So I have to break this up into 2 different intervals. I'm going to go -1 to 3, and then from 3 to infinity. We're using parentheses on all these because of the greater than symbol. If it was a greater than or equal to, then we could use brackets here. But in this case, both of these are going to be parentheses. The 3 is not included again. So the difference is, if this was greater than or equal to 0, that means I could have done -1 to infinity, and I could have a bracket on the -1. That's the difference if I would have had that kind of answer. Okay, so again, let me write that here. So if I have x plus 1, let's suppose the original problem was x plus 1, x minus 3 squared is greater than or equal to 0. Then the answer we could have written as -1 to infinity with a bracket on the -1. That's the difference between these two. The equal sign tells us that we are allowed to include the 3 that's on the number line there, because we have 2 of them together. So because it is, we'll just put a bracket at -1, and that's going to go all the way to infinity, including the 3. So that's why we don't have to break these up into 2 separate intervals. So I just wanted to show you the difference between the two. Now, of course, if you have less than or equal to, then you would just have the 1 region over here. That one would be, that's actually easier, that version, because then it would just be -infinity, -1. You just either have a parenthesis or a bracket, depending on whether it's less than or equal to. And that would be the difference in how you write your answer on this one. All right, so we have that. Okay, so then getting into one like this, This is where we're going to, this is both of these questions are the parabola type problem. So this one is going to be a multiple choice on the test. So the graphing part for number 11 will be a multiple choice. You're just going to choose the one that best resembles the shape that you come up with. So we'll do it by hand, and we'll kind of we'll draw it out first, and then we'll see, you know, my open math will just see which one matches. Okay, so this here, you want to set both of these equal to 0, and that'll get you the first blanks that are here. The first thing, if you set that equal to 0, you're going to get a -1, and then over here, if you set that equal to 0, you'll get a 3. Now the multiplicity would be the powers that are on each of the factored pieces. Okay, so on the first one, there's just a 1 there, so it's a multiplicity of 1. The 3, there's a square on that, so it's a multiplicity of 2. If it's an odd multiplicity, it's going to cross. So odd multiplicity, this is crosses, and this is touches. Okay, so they'll have that kind of thing on there. And again, it'll be similar to the homework, so you got to be careful. It'll say the least 0 would cross or touch. You want to be careful about which one they ask you to put in, because you have to read the instructions on it. When you typed it into my open math, it'll say the least 0 or the highest 0. It'll tell you something like that. That's how you know which one to put in on each of those cases. So you want to pay close attention to that, or it might say the least, the middle 0, or the highest 0. It'll say something like that to where you'll know which one to enter the blanks. Okay, so the degree, you find the degree by adding up the multiplicities. So degree is 3. The maximum in turning points is always 1 less than your degree. That's going to be a 2. For the y-intercept, you want to put in a 0 for x. So we have 0 plus 1, and we have 0 minus 3 squared like that. So that's going to give us -1 times 9. This is going to give us -9 as a result. So -9 goes there for the y-intercept. Okay. Now we want to determine the end behavior. So in other words, we want to find what's called a power function. So if I were to multiply all this out, I want to just put the leading term, the first term there. Now for this, we don't have to actually multiply all this out. If I look up here, I have a -1. This part is just going to be some kind of an x. And this part here, if I were to multiply all this out, I would get x squared plus 6x plus 9. So I get some kind of an x squared I'm multiplying together. So all I am concerned about is just the number, any numbers I see here. And I'm looking at if the x is the highest power I have for each of these parentheses. So I'm multiplying by some kind of an x here. But this one, if I multiply out, I'm multiplying by some kind of x squared. So if I multiply all those terms together, I'm going to get -x cubed. So -x cubed is going to be the power function. In other words, that's what it looks like for large values. Okay. Now for this, if I'm looking at as far as end behavior of what it looks like on the graph itself, I have n is odd, and the a of n is less than 0 because I have a negative sign in front of this leading term. So one thing you also want to know is in this section where we talked about the graphing the polynomials, I gave you 4 different charts, whether it opens up, opens down, that sort of thing. So for this, if n is odd and a of n is less than 0, then it's going to do something like this. It's going to go up and it's going to go down like that. So that would be your end behavior here on this kind of question. So first, let's put the intercepts on there. It crosses at -1 and also crosses at 3. And it also crosses down here at -9. So it'll be all the way down off the graph. It'll be down there at -9. It crosses through. So if I look at these arrows, the arrows mean it's going to come down and then it's going to end up going down this way. Now at -1, the graph is going to cross. So what I'm going to do is just draw in a line like this. Make sure it actually goes through the intercept like it's supposed to, all the way down to here. Now, of course, it's going to have to curve and then come back up this direction. Now, at this point, at 3, that multiplicity is even, so it touches. So at this point, it's going to come up here and it'll do a bounce. Okay, so it's not going to cross here. It has to go upside down. Or another way I can think of that is because there's a square on there, it's going to have to look like a parabola at that point. Whereas this just has a regular x in it, that's a linear. So we just have a line that goes through like that. And this will keep going down here forever because that's what the end behavior tells us. End behavior has to go up and then down. And so that's how I know which direction to start this from. Okay, that's how I know what the graph looks like. So you do want to make sure, even though it's not going to really ask you for the end behavior on there, you want to take a look at the power function like that. And so if you don't remember these charts like this, here's one thing you can actually do. Think about, what does this graph kind of do? If I were to draw this graph, that graph in general would have a bend in the graph and do something like this. That would still go up and it would go down like that. So you could also kind of get the end behavior kind of from what the power function looks like on that. All right, so that's that one. So again, some of your multiple choice situations, you just want to choose the correct graph. The one that most resembles the one that you have here is what you'll check. And you'll get that one in MyOpenMath. All right, now for the last one, this is actually what we were talking about this week. We learned this one. Now this is one where, although it's still going to ask you to find the list of rational zeros, on part 2, you don't have to actually guess and check every single one that you come up with in part I. Notice that for this problem, I'm giving you two of the starting zeros are already provided for you on this problem. Okay, so there's both of those are provided. So because both of those are given to you already, now you already know what 2 of the zeros are, and it says use of that division to find the other or remaining zeros. So because it says other, that means I'm not going to include these 2 on my list. So that's something you want to pay close attention to when you do the homework on there, or when you do the actual problem in the test. Let me actually look and see what it actually tells you to do here. All right, so on this one, on the answer key here, on this it says find the other zeros, but I just looked at the instructions on the actual test. Says be sure to include the original given zero. So you do want to include the original given zero or zeros, however many they give you. You do want to include those on that problem as well. All right, so in this case, it says other zeros, but I'll just list them all anyway as it is. So I already know that -1 and 1/2 are part of the zeros, so we'll just ignore that the other part here. Just find the zeros. So I'll just list the 2 original ones, and then the ones I'll come up with synthetic division, however many more there are, I'll put that on here as well. But let's first do the find the list of possible real rational zeros. So first thing we're going to do is the formula for it is always factors of the last number over factors of the first number. So I'm going to do factors of 4 over factors of 6. Okay, factors of 4 and factors of 6. Okay, now factors of 4 will be all the numbers that divide evenly into 4. Plus or minus 1, plus or minus 2, plus or minus 4. In the bottom, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So we actually have 4 factors down below there. So now when we write the list out here, we're just going to take all the numbers on top, divide by 1, all of them by 2, all of them by 3, all of them by 6. If I have any repeats, I only have to show them once. So the first part of my list here is I just have the first, these numbers on top divided by 1. So that's done. We're done with that. Then we're going to take all the numbers on top divided by 2. Okay, so that's plus or minus 1/2. Now 2/2 is a 1. We already have it on the list. 4/2 is 2. We already have that on our list. So we only have to write it again once. Next, we're going to take all the numbers on top, divide by 3. All right, so we're going to do plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. So all the numbers on top divide by 3. Okay. Now we're going to take all the numbers on top divided by 6. Okay, so I have plus or minus 1/6. Okay, then I have 2/6. Now 2 over 6 is 1/3, but we already have it on the list. We don't have to write that again. Then we have 4 over 6. That's 2/3. Already have that on our list as well. So here is our completed list. We don't have any repeats in there. And so that's all of them on there. We already see that these two that are original given zeros, they're already a number that comes from our list anyway, as we see here. -1 came from our list and 1/2 is there. So it does all the guess and check work for you by telling you the two starters. If it's a 4th power, they have to give you 2 zeros. If it's a 3rd power, though, if you take a look at this one here, for instance, that's a 3rd power. Notice they only gave you one zero. Okay, because every time you do synthetic, it takes the power down by 1. So if it's a 3rd, it only takes 1 time doing synthetic to take it down to a square. But this one, though, we have to do synthetic twice because it's a 4th power. Now, it doesn't matter which one of these that you start with. I'll start with -1. -1, put that in there, just like that. And we should get a 0 for our answer because that's what it says right here. Now, if you don't get a 0, that means you want to go back and double check because maybe you made a mistake somewhere in your work. Now, you gotta be careful with this particular problem because this problem, notice that there is a 4, a 3, a 2, but the X is missing. So I'm gonna have to put a 0 placekeeper in for this particular problem. So I have 6, -5, -15, 0, and a 4. Okay, I need a placekeeper in that one. The 6 is going to drop down. We multiply these together and put the result in the next column. So 6 times -1 is -6. I'm adding this together. I get -11. -11 times -1 is +11. I'm adding this together. I get -4. -4 times -1 is +4. Add it together, we get a 4. 4 times -1 is -4. Add it together, get a 0. Okay, 0 as expected. Okay. Now next, when we have the 1/2 that's here, we're going to put the 1/2 inside the box, but we're going to use the answers that we just came up with. We're not going to use the original coefficients. We're going to use the 6, -11, -4, and 4. Because doing it this way will allow us to take this down into a quadratic. So 6 comes down. 6 times 1/2 is 3. Adding that together, -11 plus 3 is -8. -8 times 1/2 is -4. Add it together, we get -8. -8 times 1/2 is -4. Add it up together, we get a 0 as expected. Okay. Now this here is going to turn into a quadratic. 6x squared minus 8x minus 8 equals 0. This is something that we can factor. I'm going to factor out. So in this case, we did a problem like this earlier in our review, and I mentioned in that previous problem that we can divide everything by the common factor, which in this case is 2. We could divide all that out. I'm not going to do that here. Now, the reason why is because whatever factoring thing I get in part 2, I'm going to be using in part 3 down here. So I don't want to divide everything by 2. Instead, I'm going to factor out 2 from all this. So factor out of 2, we get 3x squared. We get minus 4x minus 4 equals 0. Okay, so we're factoring out a 2. Next thing we want to do is do this. Okay, factor the 3x squared minus 4x minus 4. Now we can do this by trial and error. 3x and x we'll put in here. And then let's just try a 1 and a 4. I'm not sure what the order is going to be on that. So let's try it this way first. 3x squared, we have a 12 and a 1. That's not going to give us a 4. So let's get rid of that and put a 4 in here and a 1 in there. Let's try that. So I get a 3x squared, a 3 and a 4 like that. That doesn't work either with that combination. So what that means is that if that combination doesn't work, then we have to try and find another combination instead. So 4 and 1 didn't work. I tried it both ways. So now we'll get rid of that here. So let's get rid of that. And let's put in a 2 and a 2 instead. So see, there's different ways that you can, if you're doing trial and error, there's a couple different ways you want to try it. So I kind of went through all the other possibilities first, just to show you it is possible that you might have to go around and do a few different combinations there. But in this case, the 2 and a 2 will work because I have a 6 and a 2. If I do a minus 6 and a positive 2, will give me a minus 4. All right, so I do that one there, 3x squared minus 6 plus 2 is a minus 4x, and then it works. So that is fully factored. Now, if you take this and set it equal to 0, the 2 is not going to give you an answer. But if you take each of these and set them equal, you're going to get the other two answers of negative 2/3 and 2. Okay, so you're just taking each of these and setting them equal to 0. 3x plus 2 equals 0. X minus 2 equals 0. You'll get these here. So these are all the zeros. We're including the original ones because that's what it'll ask you to do on the test. Include the 2 original given zeros or 1, however many they give you. You'll put those down. Okay, so that answers part 2. Now for part 3, all right, so the first thing I'm going to do is write down the factored pieces I had from step number 2. So let's put that in there right away. Okay, so I have that. Now the other ones, you're going to use the 2 original given zeros. These 2 original zeros I have on my list here, -1 and 1/2. Okay, I want to put those in down here. So the way you do that is you just put x minus and then x minus whenever you want to take a 0 and turn it into a factor. I have 1 minus -1. I have 1 minus 1/2. Now there's some simplifying that I can do here. Okay, so first of all, I'm going to put the x minus 1/2. I want to put that next to the 2 here. So I'm going to move that over and put it next to the 2 like I have here. And the rest of them I have x minus 2 and x plus 1. Now the reason why that I'm doing that is the ones we did before in class for lecture, we didn't really have a result like this where you had an extra number on the outside in a fraction. But if you have a number like this and a fraction, what that's going to allow you to do, it's going to allow you to actually multiply both of those and clear out the fraction. Because in my open math, they don't want you to leave an answer with a fraction in it like that. They want you to multiply this through. So that you're going to get a 2x minus 1 here instead when you multiply that through. Okay, you know what? I forgot in the last step, I forgot the 3x plus 2. So we'll stick that on the end there. This here disappeared. That should still be there in your answer. So I'll just put that on the end. The order doesn't matter what you write these down, but this whole thing would be your answer for that. You should have 4 things there because we have 4 different zeros that came out of that. So also, if you take 2x minus 1 and you set that equal to 0, you will get the 1/2 that was on our list. And so it is done correctly there. So you'd have f of x just equals all this. Again, the ordering doesn't matter on this, how you want to put that on there, but this would be your final answer there, just like that. So again, it'll say something like that in the instructions. Let me actually look and see what exactly it says here. Yeah, so yeah, that's usually how they expect you to write the answer. If you have something like that, the question you have may or may not even have a fraction that comes up in it, but if it does, you kind of want to just follow the step that I showed here and clear out the fraction. Usually, whenever there is a fraction, there always is a number that is the same denominator that always comes out, which is how all these actually work. So you should always be able to clear out that fraction by the numbers you'll have out front. That's usually how that one is going to work for you. All right. So that is actually it for all the questions on the. I went through all the version B questions on the test, and so now I'm just going to go ahead and open it up to see if anybody has other questions on other ones or homework problem or any questions that you might have for review. We'll just leave that open now for that. Otherwise, if you don't have a question, then you can feel free to leave this meeting, and then the test again is going to be tomorrow. It's going to be open all day for you, and no lecture tomorrow either because of the test. So anybody have any questions? We got a question in the chat here. Oh, that's thank you. All right. Well, it doesn't look like anybody has any questions. So if you think of something, just go ahead and email me if you have any questions on that. So enjoy the rest of your day, and I'll see all of you guys back again on Monday because again, tomorrow is the test.